Hello Hopewell, this is Day 5 Notes in Algebra 1. You're looking at page 19 in your packet. I've added a warm-up. Unfortunately, I'm not able to be here in class today to teach this to you, but I've made a short video to help explain what you are supposed to be learning today, and I do expect that you learn it using this video. This warm-up is not featured in your packet, but we're going to do this together just to get us started. When you take the product of 3 times 0, what is our answer? Well, the answer you're thinking is probably that it equals 0, and you'd be correct. 0 times negative 1/2 in question number 2. In exercise 2, 0 times a negative 1/2 is also equal to 0. And for exercise 3, the product of 0 times itself. 0 times 0 equals 0. So why is the product 0 every time? Anytime you have a product containing one or more factors of 0, the answer will always be 0. And this leads us to the first thing we're going to talk about on page 19. That's called the zero product property. It says this: if you have a product of 2 or more factors and the answer equals 0, that means one of the factors must be equal to 0. It could be both, but at least one of those factors could equal 0. This lesson is broken down into 2 different sections, just like your homework. These are the steps on how to solve a quadratic equation by factoring. First, let's take a look and notice that the first step always has to have the equation written in standard form and set equal to 0. If I look at the bottom of page 19, none of these exercises are in standard form. These are all set equal to 0, but they're already been factored. Some of them have a GCF, some of them are factored using a T-chart. All of these are factored already for you. So on this page, we don't have to do this part. And it also means we don't have to do step 2. These are already factored for us. So how do we use the zero product property to solve a quadratic equation? That's this step, step 3. On the bottom of 19, what we're just going to practice is how do you find the answers after it's been factored. So we're here in the procedure. The zero product property says this: when you have 2 or more factors whose product is equal to 0, then either the first factor could equal 0, so I'm going to write x minus 3 equals 0, or the second factor could equal 0, so I'm going to write x plus 1 equals 0. What are the values of x that make each of these factors equal to 0? We're going to do the last step in this procedure. We're going to solve each equation. We're going to add 3 to both sides. X equals 3. We're going to subtract 1 from both sides, and x equals negative 1. We've solved our first equation, and we found both of our solutions. Let's move ahead to exercise 2. We have 1, 2, 3 factors whose product is equal to 0. Then either of these 3 factors could equal 0 to make that product equal to 0. Something I didn't do in the first exercise that I'm going to do from here on out is I like to separate my factors with these little lines and write my equations in between these lines. Take the first factor, 3, set it equal to 0. Take our second factor, 4x minus 5, and set it equal to 0. Take our last factor and set it equal to 0. This is step 3. What I notice about the first factor is it has no x, so I can't solve it. That it's not possible for the number 3 to equal 0, so this does not have a solution. For the next one, 4x minus 5 equals 0, we solve this by adding 5 first. So 4x equals positive 5. Then dividing both sides by 4. And if your answer is a fraction, you may leave it in lowest terms, 5 over 4, or if you use your calculator, it is the same thing as saying x equals 1.25. X minus 2 could equal 0. Let's solve it. Let's add 2 to both sides. X equals 2. And we have our 2 solutions. The first factor, because it doesn't contain an x, doesn't have a solution. Let's look ahead to question 3. This has already been in factored form, so we're starting with a third step in this procedure. To use the zero product property, we're going to take each factor, separately, set it equal to 0, and solve it. When we solve it, we're getting the x by itself. X equals 0. We notice the x is already by itself. There are no steps to do. This is one of my answers. Unlike the last exercise, 3 cannot equal 0 because we don't have an x in here to get alone or by itself, and these numbers are not equal to each other. In this exercise, x equals 0 means that the value of x which makes this factor equal to 0 is the number 0 itself. We're going to solve the second equation to get the x by itself. So we're going to add 4 to both sides. 3x equals 4. Then divide by positive 3. You may leave it as a fraction in lowest terms, or if you use your calculator, it will tell you 1.3 repeating. So I put the little repeating or repetition bar on top of the 3 to make sure that the decimal goes on forever. And these are those two answers. So I'm going to do the last one, and then maybe only set up the last two and see if you can do them by yourself. So in exercise 4, it's already in factored form. We're going to separate the first equation, the second equation. Either pause the video or figure out what the answers are going to be, or figure out what the equations are going to be before I do it. 2x minus 7 equals 0. 2x plus 7 equals 0. What would we do next? Solve this. You may pause the video. We're going to add 7 to both sides. 2x equals 7. Divide by 2. X equals 7 over 2, or 3.5. In this one, we're going to subtract 7 from both sides. 2x equals negative 7. X equals negative 3.5. For these last two exercises, I'm not going to solve them all the way completely. I'm just going to set up the two equations for each exercise. Pause the video and then resume watching the video to see if your answers are correct. (2x equals 0). X plus 4 equals 0. For number 6, x minus 9 equals 0. 3x plus 99 equals 0. You can solve each of these four equations and find the answers to this. I'm going to move ahead to page 20. Turn the page. In section 2, and also like section 2 on your homework, you'll notice that all of your equations are set equal to 0, but are not in factored form. They're in standard form, from highest degree to lowest degree. This page I'm supposed to remind you of all the different methods for factoring. Greatest common factor, difference of two squares, T-chart, grouping with 3 or 4 terms. Let's find an example that's greatest common factor. There are a few that are on here. Number 5 is a greatest common factor example or exercise. With the two terms, there is a number and a letter that can be factored out, 7x. When you reduce each of these fractions, they become x plus 2 equals 0. Just like the previous page, we're going to set each factor equal to 0 and solve by undoing the operations that are being performed on your x. And that's how you would solve by factoring using GCF. Let's look for something that's dots. Dots has a minus sign between two perfect squares. These are not perfect squares. These are perfect squares, 25x squared minus 36. So we're going to square root each term. This one again is dots. The square root of 25x squared is 5x. The square root of 36 is 6. So our factors are going to be 5x 1 plus sign, 6, and 5x 1 minus sign, plus, or 5x minus 6, excuse me. Then we're going to separate each factor and set them equal to 0 and solve. minus a 6. So 5x equals negative 6. Divide by 5. X equals negative 1.2. Add 6 to both sides. 5x equals 6. Divide by 5. X equals 1.2. That's GCF and dots. How about a t-chart? T-charts always start with a 1x squared. The constant at the end goes on the first line. The middle coefficient goes on the next. What are factors of negative 18 that add up to make negative 7? The first pair adds up to be 17. The next pair adds up to be positive 7, so we're going to reverse our numbers to make a negative 7. It's important to remind you to make this equal to 0. Because it's an x squared and it's t-chart, each of these factors begin with an x, minus 9 and a plus 2. I'm not going to finish this exercise. You're going to set each factor equal to 0 and solve it. Instead, I'm going to look for grouping. Grouping happens when the leading coefficient isn't a 1 and it can't factor out using a greatest common factor. We're going to multiply the a and the c together to get negative 60. Next to it is our b value, negative 11. Negative 1 and 60 doesn't work. Negative 2 and 30 doesn't work. Negative 3 and 20 doesn't work, but each time I'm getting closer to an 11. Negative 4 and 15 make positive 11, so I know that all I need to do is switch the signs to get my negative 11. 3x squared is our first term. Minus 15x plus 4x together, they make the negative 11x in the middle, and at the end is minus 20. Now you're going to factor the greatest common factor for each group. This is going to be a 3x, x minus 5. This is going to be a 4, x minus 5. We have a match. 3x plus 4, our GCFs on the outside go in one parentheses, and the match goes in the other, x minus 5. And one more time, I'm not going to finish this exercise. You're going to set each factor equal to 0 and solve it. This also works if there's 4 terms when you group. And when there's 4 terms, we have to make sure that there's a plus sign in between my two groups, and also we don't have dots. If we do have dots, we continue to go on. We continue to factor. The GCF of our first group is x squared. The GCF of our second group, because it starts with a negative, has to be a negative number in this case, negative 3, 2x minus 7. This matches, and we don't have dots. So this is as factored as it gets. We're going to set each factor equal to 0 and solve it. Something weird happens this time. When you add 3 to the other side, you're solving this by square rooting. We previously discussed this. You're going to square root the left side and the right side, so x equals plus or minus. Now the square root of 3 isn't a whole number, it gives me a decimal. So we're just going to leave our answer as plus and minus square root of 3. This one is regular or normal way of solving for an x. 7 over 2 is the same thing as 3.5. So, in the final minute that we got together left, you should be able to do your homework. Homework is on page 21 only. These two are already factored exercises. You want to split them up into 2 equations and solve for x. In the second section of homework, like page 20, you're going to make sure everything's in standard form, set equal to 0, and factor using t-chart, grouping, dots, and all the other methods that you have. You're going to factor it and then set each factor equal to 0 to solve it. Do the best that you can to complete your homework. We're going to check the other homework the next time we see you. And then don't forget to submit your attendance for today. It's on a Google form. Best of luck to you. Have a great day.